Welcome to Milky Narratives. As the world around you grows quiet, allow your mind to slow down and your imagination to awaken. Tonight, we journey through distant galaxies, forgotten worlds, and the endless silence between the stars. 1. The stars that escape time. Some stars have been shining for almost the entire age of the universe, quietly surviving while countless generations of galaxies changed around them. Imagine finding a candle that has been burning continuously since before the first forests covered the Earth, before the dinosaurs, before our sun even existed. Now imagine discovering that this candle has not burned for thousands of years, or even millions, but for nearly the entire lifetime of the universe itself. It sounds impossible. Everything we know eventually grows old. Mountains crumble, oceans shift, stars explode. Even galaxies collide, merge, and transform into entirely new shapes. The universe seems to be a place where nothing lasts forever. And yet, scattered quietly across the cosmos are stars that seem to have escaped time itself. They have watched generations of brighter stars live and die. They have witnessed galaxies grow from youthful spirals into ancient collections of aging suns. Some were already shining long before the Milky Way became the majestic galaxy we call home. Tonight, we'll journey to meet these extraordinary survivors, the oldest stars still burning, the quiet witnesses to nearly everything that has ever happened in cosmic history. Because sometimes, the longest stories are told not by the brightest stars, but by the ones patient enough to simply keep shining. When we picture stars, we often imagine brilliant blue giants blazing with unimaginable energy. They dominate photographs taken by powerful telescopes. Their intense light carves glowing clouds into magnificent shapes. Some are dozens of times larger than our sun. Others shine hundreds of thousands of times more brightly. They appear powerful, almost immortal. Yet appearances can be wonderfully misleading. The brightest stars are often the shortest lived. Their enormous masses create tremendous pressure deep inside their cores. Hydrogen fuses into helium at astonishing rates. Energy pours outward in spectacular abundance. But such brilliance comes at a cost. These stellar giants consume their nuclear fuel with incredible speed. Some survive only a few million years. In cosmic terms, they are brief flashes of light. Imagine two candles. One burns with a towering flame that fills an entire room with light. The other glows softly in the corner. The first disappears before the night is over. The second quietly burns until morning. The universe has always favored the patient flame. The oldest surviving stars are rarely the most spectacular. Many belong to a class astronomers called red dwarfs. They are small, cool, dim compared with stars like our sun. At first glance, they hardly seem remarkable at all. Yet hidden inside their modest appearance lies one of nature's greatest achievements: efficiency. Unlike massive stars, red dwarfs burn their hydrogen incredibly slowly. Gravity compresses them just enough to sustain gentle nuclear fusion. Their temperatures remain relatively low. Their energy output stays modest. Nothing is rushed. Every atom of hydrogen is used carefully. Almost nothing is wasted. Some calculations suggest that the smallest red dwarfs could continue shining for trillions of years. Not billions, trillions. That is hundreds of times longer than the current age of the universe. In fact, something astonishing follows from this prediction. The universe is not yet old enough for even a single red dwarf to have reached the end of its natural life. Every red dwarf ever born still exists today. Not one has completely burned out. Think about that for a moment. White dwarfs are the remains of dead stars. Neutron stars mark the collapsed hearts of massive suns. Black holes represent gravity's final triumph over stellar giants. But no red dwarf has yet had enough time to become any of those things. Every one of them continues patiently glowing. The oldest are still in the early chapters of lives that will far outlast our entire cosmic era. In a sense, they are stars that have escaped time, not because time has stopped for them, but because their clocks tick almost unimaginably slowly. Long before astronomers understood this, nature had already scattered these quiet survivors throughout the universe. In fact, red dwarfs are not rare at all. They are the most common type of star in the Milky Way. Roughly 3 out of every 4 stars belong to this humble family. Ironically, the stars most likely to survive the longest are also among the easiest to overlook. They shine too faintly to dominate the night sky. Many cannot even be seen with the naked eye from Earth. Our own nearest stellar neighbor, Proxima Centauri, is a red dwarf. Despite being the closest star beyond the Sun, it remains invisible without a telescope. Sometimes the greatest survivors prefer not to attract attention. Yet red dwarfs are only part of the story. Astronomers have also discovered ancient stars whose ages approach the very beginning of cosmic history. Some formed only a few 100 million years after the Big Bang. These are known as population 2 stars, stellar elders born when the universe contained very few heavy elements. Their chemistry tells their remarkable story. Modern stars, including our Sun, contain noticeable amounts of carbon, oxygen, iron, silicon, and many other elements forged inside previous generations of stars. The oldest stars do not. Their atmospheres remain extraordinarily poor in heavy elements because almost none yet existed when they formed. They are living fossils, not because they stopped changing, but because they preserve memories from an almost forgotten age. One famous example is a star cataloged as SMSSJ 031300.36-6708339.3. It contains so little iron that astronomers believe it formed from material enriched by one of the very first supernovae ever to occur. Looking at such a star is almost like hearing an echo from the universe's earliest childhood. Its light has traveled across billions of years carrying information no history book could ever record. Imagine if a single tree had survived since the first forests appeared on Earth. Scientists would treasure every ring inside its trunk, every scar upon its bark. Every leaf would tell a story of climates and seasons long forgotten. Ancient stars offer astronomers something remarkably similar. Their chemical fingerprints reveal conditions that existed before galaxies fully matured, before planets became common, before life had any opportunity to appear. Each one quietly preserves a page from the universe's oldest diary. Perhaps even more astonishing is the realization that many of these ancient stars have not remained in the same surroundings. Galaxies grow by swallowing smaller galaxies. Stars migrate through gravitational interactions. Entire stellar populations are rearranged over billions of years. A star born in a tiny dwarf galaxy may now orbit peacefully inside the Milky Way after its original home was absorbed long ago. The galaxy changed. The star endured. It escaped not only time, but history itself. Even our own Sun is only a temporary participant in this immense story. It is about 4.6 billion years old, ancient by human standards, but relatively young compared to many stars scattered across the galaxy. When the oldest surviving stars first ignited, our solar system did not exist. Earth did not exist. The atoms making up your body floated as simple hydrogen drifting through interstellar space. Eventually, ancient stars forged heavier elements. They exploded. Their material enriched future clouds. One such cloud eventually collapsed into the Sun and its family of planets. In a profound sense, every heartbeat owes something to stars far older than our own. There is something deeply comforting about these quiet survivors. Human lives often feel brief. Civilizations rise and fall. Languages evolve. Entire cultures disappear into history. The universe gently reminds us that some lights continue shining through almost unimaginable stretches of time. Not because they resist change, but because they embrace patience. Perhaps endurance is not about burning brighter. Perhaps it is about burning wisely. One gentle flame, one quiet heartbeat of fusion, 1 billion years after another. And somewhere above us tonight, ancient stars continue glowing as they always have, patiently watching galaxies transform around them, keeping silent company with a universe that never stops changing, while they quietly become some of the oldest lights that time could never quite leave behind. 2. The islands floating in endless darkness. Imagine discovering an entire galaxy so isolated that, for billions of years, it has barely met another neighbor in the expanding universe. Imagine sailing across an endless ocean for weeks, months, years. The horizon never changes. No distant coastline appears. No passing ships interrupt the silence. No lights glow in the darkness. Only the quiet sea stretching endlessly in every direction. Eventually, you begin to wonder whether the rest of the world still exists at all. Now imagine that your lonely island isn't surrounded by water, but by millions of light years of empty space. Its beaches are made of stars. Its mountains are enormous clouds of glowing gas. Its forests are spiral arms filled with billions of suns. And for billions of years, it has drifted almost entirely alone through the expanding universe. Tonight, we'll visit some of the loneliest islands ever discovered. Entire galaxies so isolated that they have lived peaceful lives while the rest of the universe gathered into crowded cities of stars. We'll discover why these forgotten galaxies became nature's greatest time capsules, and why sometimes the quietest places preserve the oldest stories. When most people imagine galaxies, they picture crowded neighborhoods. The Milky Way belongs to a small gathering known as the local group. Our nearest giant companion, Andromeda, lies only about 2.5 million light-years away. Dozens of smaller dwarf galaxies quietly orbit both of them. Far beyond, thousands of additional galaxies gather into even larger clusters and superclusters. From the largest perspective, the universe resembles an immense network of glowing cities connected by invisible highways, crowded, busy, constantly evolving. It almost feels impossible that any galaxy could truly become isolated. After all, gravity has spent nearly 14 billion years pulling matter together. Wouldn't everything eventually find company? Surprisingly, the answer is no. While gravity gathers some regions into magnificent clusters containing thousands of galaxies, cosmic expansion quietly separates others. The universe is not growing into one enormous city. It is becoming a place of extraordinary contrasts. Some neighborhoods become busier with time. Others slowly drift farther from everyone else. Imagine blowing tiny drops of paint onto the surface of an expanding balloon. As the balloon grows larger, every drop moves away from every other drop. If some drops begin close together, they may remain neighbors. Others, starting farther apart, become increasingly isolated forever. Galaxies experience something remarkably similar. One of the most fascinating examples astronomers have found is a class known as isolated galaxies. These systems spend billions of years without significant encounters with nearby galaxies. No major collisions, few close gravitational disturbances, almost no dramatic interactions. Compared with galaxies inside dense clusters, they live astonishingly peaceful lives. If galaxies could remember history, these lonely islands might describe the universe as a remarkably quiet place. One famous example is NGC 6503. Sometimes called the Lost in Space Galaxy, it drifts near the edge of a vast cosmic region known as the local void. Its nearest substantial galactic neighbors lie astonishingly far away. From inside such a galaxy, the universe would appear profoundly different. The night sky would still contain countless stars belonging to its own spiral disk. Nebulae would glow softly. Planets could still orbit peaceful suns. Life, if it existed, might flourish beneath familiar constellations. But beyond the galaxy itself, darkness would dominate. The surrounding universe would appear strangely empty. Civilizations there might spend centuries searching for neighboring galaxies before discovering just how alone they truly are. Perhaps they would wonder whether galaxies themselves were rare. Perhaps they would believe their own island was the center of everything. Perspective shapes knowledge more than we often realize. Here on Earth, we discovered countless galaxies because the universe kindly placed us inside a region rich with neighbors. Elsewhere, understanding the true scale of the cosmos might prove far more difficult. Loneliness can shape science. Yet isolation also offers remarkable advantages. Galaxies living inside crowded clusters experience constant gravitational encounters. Nearby companions pull upon their spiral arms. Gas clouds become compressed. New stars burst into existence. Sometimes entire galaxies collide and merge. Over billions of years, their original structures become almost impossible to recognize. Isolated galaxies avoid much of this cosmic chaos. Without frequent disturbances, they evolve far more gently. Their spiral arms remain elegant. Their gas settles peacefully. Their histories become easier to read. Astronomers treasure these quiet systems because they preserve clues about what galaxies naturally become when left almost entirely undisturbed. It is rather like finding an ancient village untouched by modern development. Every street, every building, every pathway tells an older story. Sometimes silence becomes the greatest historian. Even more extraordinary are galaxies hidden inside enormous cosmic voids. These immense regions can stretch hundreds of millions of light years across while containing remarkably few galaxies. Imagine shrinking the Milky Way until it becomes one tiny island floating inside an ocean larger than anything human imagination comfortably accepts. The distances involved almost defy comprehension. Light itself may require tens or even hundreds of millions of years to cross from one side of a void to the other. Inside these quiet regions, galaxies often continue living relatively uneventful lives. Star formation proceeds. Stars age. Supernovae occasionally bloom. Black holes quietly feed. Yet, the outside universe barely interrupts them. While crowded galaxy clusters resemble bustling cities, void galaxies feel more like isolated cottages standing alone on endless plains. Neither is more important. They simply tell different chapters of the universe's story. There is another beautiful consequence of isolation. Because these galaxies experience fewer mergers, some preserve ancient disks that have remained surprisingly stable for billions of years. Astronomers studying them gain precious insight into how galaxies may have appeared during much earlier cosmic eras. Instead of reconstructing history from scattered evidence, they observe systems that have quietly preserved it. Nature often hides her oldest memories in the quietest places. Even the stars inside isolated galaxies tell remarkable stories. Without repeated bursts of star formation triggered by collisions, many stellar populations age gradually together. The brightest blue stars eventually disappear. Gentle yellow and orange stars become more common. Red dwarfs patiently continue their unimaginably long lives. The entire galaxy grows older with extraordinary grace. Not suddenly, not dramatically, simply one quiet generation at a time. Perhaps there are planets orbiting some of those distant stars. Worlds where intelligent civilizations gaze upward into unusually empty skies. Without nearby galaxies decorating the darkness, their astronomers might initially conclude that the universe contains only a handful of island galaxies scattered across infinite space. Only after building larger telescopes would they slowly uncover the faint glow of distant clusters resting near the horizon of visibility. Imagine the wonder of realizing that countless unseen islands had always existed beyond the darkness. Sometimes discovery begins with loneliness. the future may make these isolated galaxies even lonelier. As the expansion of the universe continues accelerating, distant galaxies gradually move beyond one another's observable horizons. Over unimaginable spans of time, many galaxies will simply disappear from each other's skies. Not because they are destroyed, but because space itself stretches too quickly for their light ever to arrive again. Civilizations living trillions of years from now may believe their own galaxy is the only one in existence. The great cosmic archipelago will quietly fade from view. Isolation, in some sense, may become the universe's final condition. There is something strangely peaceful about these forgotten islands. We often imagine that importance comes from being surrounded by activity. The universe gently offers another perspective. Some of its most valuable memories survive precisely because they were left undisturbed. The quietest galaxies preserve stories the busiest ones have already forgotten. Perhaps solitude is not always emptiness. Sometimes it is preservation, and somewhere beyond the crowded neighborhoods of the cosmic web, a lonely spiral galaxy continues turning beneath an almost empty sky, patiently orbiting through billions of years of silence. Its billions of stars shining together like a single island lighthouse, floating peacefully in an endless ocean of darkness. 3. The invisible rivers that carry new suns before a star is ever born. Invisible rivers of ancient hydrogen have already begun their slow journey toward its future home. Imagine planting a tree. Months pass before the first leaves appear. Years pass before its branches begin reaching toward the sky. To most people, the tree's story seems to begin the moment it breaks through the soil. But the real story started much earlier. It began with rain falling on distant mountains, with rivers carrying water across valleys, with tiny seeds waiting patiently beneath the earth long before anyone noticed them. Stars are born in much the same way. When we look through powerful telescopes, we often see brilliant nurseries glowing with newborn suns. Clouds of pink hydrogen shimmer beneath the light of young stars. Nebulae bloom across the darkness like enormous celestial flowers. It is tempting to believe that this is where the story begins, but it isn't. Long before the first spark of nuclear fusion, long before gravity gathers enough gas to ignite a star, ancient rivers have already been flowing through the universe. Invisible rivers. Slow rivers. Rivers carrying the oldest element in existence toward places where future stars are quietly waiting to be born. Tonight, we'll follow those remarkable currents. We'll discover how galaxies never truly create stars from nothing, how the universe patiently recycles its oldest material, and why every sunrise on Earth may have begun with a river that started flowing nearly 14 billion years ago. Hydrogen is the simplest atom nature can build. One proton, one electron, nothing more. Yet from that extraordinary simplicity came nearly every shining object we see in the night sky. Only a few minutes after the Big Bang, the first hydrogen nuclei appeared. Hundreds of thousands of years later, when the universe finally cooled enough for electrons to settle into stable atoms, enormous oceans of hydrogen spread across the young cosmos. At that time, there were no stars, no galaxies, no planets, only an expanding universe quietly filled with this invisible sea. Gravity slowly began gathering portions of that hydrogen into denser regions. Tiny differences became larger. Clouds formed. The first stars eventually ignited. But surprisingly, gravity did not collect all the hydrogen. Vast quantities remained drifting between galaxies. Some still drift there today. These immense reservoirs form what astronomers call the intergalactic medium. At first glance, it seems almost empty. In many places, only a handful of atoms occupy an entire cubic meter of space. Yet, because the universe is unimaginably vast, these scattered particles together outweigh all the stars in countless galaxies. The quiet rivers begin here. They do not resemble rivers on Earth. There are no rushing currents, no waterfalls, no winding channels cutting through stone. Instead, gravity creates gentle flows so slow that a single journey may require hundreds of millions of years. Hydrogen atoms drift almost imperceptibly toward galaxies, following invisible paths shaped largely by dark matter. Astronomers often describe these pathways as cosmic filaments. Seen on the largest scales, the universe resembles an enormous web. Galaxies sit where multiple filaments intersect. Between them stretch long, delicate strands of invisible matter and gas. These are the rivers of the cosmos, patiently carrying tomorrow's stars, one atom at a time. Imagine watching a river frozen almost completely in time. Instead of water racing downstream in seconds, each movement occurs over millions of years. From a human perspective, it would appear perfectly still. Yet viewed across cosmic history, the current never stops. The universe rarely hurries, it simply continues. When hydrogen flowing through one of these invisible rivers finally approaches a galaxy, gravity begins pulling it inward more strongly. The gas slowly falls toward the galaxy's outer regions. Sometimes it joins enormous clouds already orbiting the galactic disk. Sometimes it arrives in cooler streams that penetrate surprisingly deep before mixing with surrounding gas. Astronomers call this process cold accretion. Although the word cold may sound unusual, these streams remain relatively cool compared with the extremely hot gas surrounding many massive galaxies. For decades, scientists believed galaxies grew primarily by colliding with one another. Those dramatic mergers certainly happen. But modern computer simulations and increasingly powerful telescopes reveal another quieter process. Many galaxies spend much of their lives simply drinking from these invisible rivers, not through sudden violence, but through steady nourishment. Imagine an ancient oak tree. Its branches spread wider each year. Its leaves return every spring. Visitors admire the trunk, the canopy, the beauty above ground. Few notice the quiet roots beneath the soil drawing water day after day. Galaxies behave in much the same way. Their glowing stars capture our attention. Yet beneath the visible beauty lies an unseen network, quietly supplying the raw material for future generations of suns. Without those hidden rivers, many galaxies would have exhausted their gas billions of years ago. Star formation would have slowed dramatically. The universe might look very different tonight. Our own Milky Way continues receiving fresh hydrogen even now. Some arrives from nearby gas clouds. Some comes from faint streams connecting our galaxy to its larger cosmic environment. Every few years, somewhere within the Milky Way, gravity gathers enough of this ancient material to begin another star. Perhaps at this very moment, a cloud is quietly collapsing thousands of light years away. Deep inside its cold darkness, hydrogen atoms that drifted across intergalactic space for billions of years are finally meeting one another. Pressure rises, temperature climbs, gravity patiently tightens its embrace. One day, a new sun will ignite. Its planets may eventually form. Perhaps oceans will appear. Perhaps life will emerge. The beginning of that unimaginable future started with an invisible river long before the star itself existed. There is another beautiful aspect to these cosmic currents. They do not carry only hydrogen forever. Stars eventually manufacture heavier elements: carbon, oxygen, silicon, iron. When massive stars explode as supernovae, those elements are thrown back into surrounding space. Powerful galactic winds can even push some material beyond the edges of galaxies entirely. Eventually, portions of that enriched gas mix once again with the intergalactic medium. The rivers continue flowing, but now they carry richer ingredients. Future stars inherit them. Future planets form from them. Future living worlds become possible because earlier generations quietly shared their atoms with the cosmic streams. The universe seems remarkably generous. Nothing truly belongs to one star forever. Everything eventually returns to the current. astronomers have begun observing these invisible rivers directly. By studying the light from distant quasars, they detect faint absorption patterns created by hydrogen drifting between galaxies. Modern instruments can even map enormous gas streams surrounding young galaxies in the distant universe. The pictures are subtle, nothing like the colorful photographs people often associate with astronomy. Yet their importance is profound. For the first time, humanity is beginning to see the hidden circulation system that keeps galaxies alive. It is rather like discovering the veins beneath living skin, invisible from a distance, essential up close. There is something deeply peaceful about this realization. Nature rarely creates through sudden miracles. A forest depends on rainfall that began as ocean mist. A river begins as tiny snowflakes falling high in distant mountains. Likewise, every star begins with quiet journeys taking place long before its first light ever appears. The universe builds through patience. One hydrogen atom joins another. A cloud slowly grows heavier. Gravity gently pulls. Time does the rest. Perhaps that is why the night sky feels so calm. Behind every brilliant star lies a story that unfolded almost too slowly to imagine. A story of invisible rivers crossing unimaginable distances. A story of ancient hydrogen refusing to hurry. A story that reminds us the greatest creations in the universe are often prepared in complete silence. And somewhere tonight, beyond the glowing spiral arms of the Milky Way, an unseen river continues carrying ancient hydrogen toward a cloud that has not yet become a star, preparing another sunrise, another solar system, perhaps even another world where someone will one day look upward and wonder. Never realizing their own star's journey began billions of years earlier, as a quiet river flowing through the endless darkness. If these peaceful journeys through the universe help you relax before sleep, consider subscribing so we can continue discovering its hidden wonders together. 4. The places where the universe forgot to build. Some regions of space are so astonishingly empty that a traveler could drift for millions of light years without finding another galaxy. Imagine standing in the middle of the largest desert on Earth. The horizon stretches endlessly in every direction. No cities, no forests, no rivers, only silence carried by the wind. Now imagine that instead of sand, there is only darkness. Instead of a few hundred miles, the emptiness stretches for hundreds of millions of light years. No neighboring galaxies, no brilliant clusters of stars, no glowing nebulae decorating the distance. Only an ocean of almost perfect nothingness. It sounds like science fiction. Surely the universe, with its countless galaxies and billions upon billions of stars, couldn't contain places that empty. After all, every image from our telescopes seems crowded with light. Every deep observation reveals another galaxy hiding behind the last. The cosmos appears overflowing with structure. And yet, some of the largest places ever discovered contain almost nothing at all. These are the cosmic voids, enormous regions so empty that astronomers once struggled to believe they were real. Tonight, we'll drift into these forgotten places. We'll discover why the universe left them almost untouched, how their silence helps shape everything around them, and why the greatest structures in existence are defined not only by what they contain, but by what they never became. When we look at photographs of the night sky, it is easy to believe that galaxies are scattered almost randomly. A spiral galaxy here, an elliptical galaxy there, a distant cluster glowing softly near the edge of the image. For centuries, that seemed like a reasonable picture. But as astronomers began mapping larger and larger portions of the universe, something remarkable emerged. The galaxies were not scattered at random. Instead, they formed an immense network. Long filaments stretched across hundreds of millions of light years. Clusters gathered where several filaments crossed. Between those glowing threads lay enormous empty regions. Imagine a sponge, The solid material forms a delicate network. Most of its volume, however, is made of empty holes. The large-scale universe looks surprisingly similar. The galaxies occupy only a tiny fraction of space. Most of the observable cosmos consists of vast regions where almost nothing has gathered. One of the most famous examples is the quietest void. Discovered in 1981, it spans roughly 330 million light-years across. To appreciate its scale, imagine placing our entire Milky Way inside it, then add another galaxy every few million light-years. Even after doing that, the region would still appear astonishingly empty. If the Milky Way happened to lie near its center, our nearest significant neighboring galaxies would be unimaginably farther away than they are today. The familiar night sky would look profoundly different. Perhaps entire civilizations would never realize that billions of galaxies existed beyond their lonely horizon. The universe would appear almost empty. Why would nature create such immense deserts? The answer reaches back almost to the beginning of cosmic history. Shortly after the Big Bang, matter was distributed with tiny imperfections. Some regions contained just slightly more material than average. Others contained slightly less. The differences were incredibly small, only about 1 part in 100,000. Yet gravity is wonderfully patient. The denser regions gradually attracted more matter. As they became heavier, their gravitational pull strengthened. They gathered still more material. Meanwhile, the slightly emptier regions lost matter to their growing neighbors. Over billions of years, the rich became richer, the poor became poorer. Eventually, galaxies crowded into filaments and clusters, leaving enormous voids behind. The universe never intentionally built emptiness. It simply kept building everywhere else. In that sense, these cosmic voids are places the universe quietly forgot to finish. Yet calling them empty can be a little misleading. They are not perfect vacuums. A few lonely galaxies still drift within them. Thin clouds of hydrogen remain scattered across the darkness. Dark matter quietly extends through these regions as well, though at much lower densities than elsewhere. Even light crosses them constantly. Still, compared with the bustling neighborhoods surrounding galaxy clusters, the voids feel almost unbelievably peaceful. Imagine standing inside the world's largest library after every book has been removed except one. Technically, the library is not empty, but emotionally, it certainly feels that way. These quiet regions offer astronomers something surprisingly valuable. Because so little happens inside them, they provide natural laboratories for studying the universe under unusually gentle conditions. Galaxies living inside voids experience fewer collisions, less gravitational disturbance, fewer bursts of intense star formation. Many evolve slowly and peacefully for billions of years. Without the chaos of crowded environments, they preserve clues about how galaxies naturally mature when left almost entirely alone. Sometimes, silence reveals truths that noise hides. The emptiness itself also influences everything surrounding it. Gravity works in both directions. Dense galaxy clusters pull matter inward. Voids, by containing relatively little matter, allow surrounding regions to expand away more easily. It is rather like valleys between mountains. The valleys themselves do not push the mountains apart, yet their presence shapes the entire landscape. Likewise, cosmic voids help guide the flow of galaxies across the universe. Even nothing can become part of the architecture. Perhaps the most fascinating aspect of these forgotten places is their unimaginable scale. Human beings naturally struggle to picture millions of light years. Hundreds of millions become almost impossible. Suppose you could travel at the speed of light, the fastest speed nature allows. Even then, crossing one enormous void might require several 100 million years. When the journey began, dinosaurs had not yet appeared on Earth. By the time you finally reached the opposite side, entire branches of life would have evolved and vanished. Civilizations would have risen countless times. Continents themselves would have shifted. The voyage across emptiness alone would outlast nearly everything familiar to humanity. And still, you would have traveled through a place considered mostly empty. There is another remarkable consequence of living near a void. Astronomers have found evidence that galaxies along the edges of these enormous regions slowly drift outward as the universe evolves. The emptiness effectively grows larger over time, not because something actively removes galaxies, but because gravity keeps drawing matter toward denser regions elsewhere. The cosmic web gradually becomes more pronounced, its filaments brighter, its voids emptier. The universe continues refining its own architecture. Patiently, almost artistically. Some scientists have even suggested that future civilizations living deep inside isolated galaxy groups may eventually lose sight of the broader universe altogether. As cosmic expansion continues accelerating, distant galaxies will slowly disappear beyond the observable horizon. One day, observers may see only their own local collection of stars. The great cosmic web will become invisible. The vast voids will no longer be measurable. Future astronomers might conclude that their lonely galaxy is all that exists. How extraordinary it is that we live during an era when the larger design remains visible. Perhaps that is one of the universe's quiet gifts. There is something unexpectedly beautiful about these forgotten places. We often associate emptiness with absence, with loneliness, with things that never happened. The cosmos gently suggests another possibility. Sometimes emptiness is not failure, it is contrast. Without darkness, stars would lose their brilliance. Without silence, music would lose its meaning. Without valleys, mountains would feel smaller. The universe did not simply build galaxies, it also built the spaces between them. Together they form a masterpiece neither could create alone. And somewhere beyond the crowded clusters of the cosmic web, a solitary galaxy continues turning beneath an almost empty sky, surrounded by hundreds of millions of light years of quiet darkness, drifting through a place where the universe almost forgot to build, leaving behind one of the greatest silences ever created. 5. The mountains hidden beneath the cosmos. The universe may contain invisible mountains so enormous that entire galaxies quietly orbit around them without ever seeing what they're circling. Imagine standing in a vast valley before sunrise. The darkness is so complete that you cannot see the mountains surrounding you. The air feels calm. The ground beneath your feet seems perfectly flat. Nothing suggests that towering peaks rise all around. Yet every river flowing through the valley, every forest growing along its slopes, every path winding across the landscape, has been shaped by mountains hidden in the darkness. You don't have to see them for them to define the world around you. The universe has mountains like these, not made of stone, not covered with snow, not visible through even our most powerful telescopes. They are mountains of gravity, invisible giants whose presence quietly guides the motions of entire galaxies. For billions of years, countless stars have circled these unseen peaks, never once catching a glimpse of the structures directing their journeys. Tonight, we'll climb these invisible mountains. We'll discover why galaxies often orbit things they cannot see, how hidden landscapes shape the largest structures in existence, and why the universe may be built upon foundations that remain forever invisible. When ancient people looked toward distant mountain ranges, they often believed the peaks marked the edges of the world. Mountains seemed permanent, unmoving. Everything else flowed around them. Rivers changed course, forests expanded, clouds drifted overhead. The mountains simply remained. Gravity creates remarkably similar landmarks throughout the cosmos, except these mountains cannot be seen. To understand them, we must first imagine something surprisingly simple. Place a heavy bowling ball on a stretched blanket. The fabric sinks beneath its weight. Now roll a marble across the blanket. The marble naturally curves toward the lowest point. The bowling ball never reaches out and grabs it. Instead, the landscape itself guides its motion. Einstein realized that gravity behaves in much the same way. Mass bends space and time. Stars and galaxies simply follow those invisible curves. The greater the mass, the deeper the valley becomes. But the universe contains landscapes far larger than any single star. Long before galaxies fully formed, dark matter had already begun gathering into enormous structures. Unlike ordinary matter, dark matter neither shines nor absorbs light. It remains invisible. Yet it possesses gravity. Over billions of years, dark matter collected into vast halos surrounding future galaxies. Imagine an invisible mountain buried beneath fresh snow. The mountain determines the shape of the snow above it. Likewise, dark matter quietly determined where ordinary gas would accumulate. Hydrogen drifted downward into these invisible gravitational valleys. Clouds became denser. The first stars ignited. Galaxies were born. From a distance, we naturally admire the stars. But beneath every glowing galaxy lies a much larger hidden structure. A mountain no telescope can photograph directly. The Milky Way itself rests inside one of these enormous halos. Our visible galaxy stretches roughly 100,000 light-years across. Its invisible dark matter halo extends several times farther. If our galaxy were a small village resting in a valley, the surrounding gravitational mountain would stretch far beyond every horizon. Every star orbiting the Milky Way quietly follows pathways shaped by this unseen landscape. Even our own sun, traveling around the center of the galaxy once every 230 million years, never leaves the embrace of this invisible mountain. Remarkably, astronomers did not discover these hidden structures by seeing them. They discovered them by watching how galaxies move. During the 1970s, astronomer Vera Rubin carefully measured the speeds of stars orbiting distant galaxies. According to the visible matter alone, stars near the outer edges should have moved much more slowly than those closer to the center. Instead, they kept racing around at nearly the same speed. Something unseen was providing additional gravity. Something enormous surrounded every galaxy. Without it, the outer stars should have escaped into intergalactic space long ago. The invisible mountains had quietly revealed themselves. The same mystery appears on even grander scales. Galaxies themselves gather into enormous clusters. Some clusters contain thousands of galaxies, each moving through space at astonishing speeds. Yet the visible matter inside those clusters is nowhere near sufficient to hold everything together. Again and again, astronomers reach the same conclusion. Most of the mass is hidden. Imagine watching leaves swirling around an invisible whirlpool. You cannot see the water beneath, but every leaf reveals its presence. The galaxies behave in exactly this way. Their motions sketch the outlines of mountains made entirely of gravity. Sometimes these hidden landscapes become visible in an indirect and beautiful way. When light from a distant galaxy passes near an enormous concentration of mass, gravity bends the light itself. Astronomers call this gravitational lensing. A distant galaxy may appear stretched into glowing arcs or duplicated into multiple images. It is rather like looking through the curved surface of a glass bottle. The glass bends the light. The image changes. In the universe, invisible mountains of gravity become cosmic lenses. They quietly distort the appearance of galaxies lying far beyond them. Through these graceful distortions, scientists can actually map the hidden distribution of dark matter. For the first time, humanity has begun drawing maps of landscapes that emit no light whatsoever. Perhaps the most astonishing discovery is how these invisible mountains connect. Dark matter halos do not exist in isolation. Many are linked together by enormous filaments stretching across hundreds of millions of light years. Galaxies form where several filaments intersect. much like towns growing where mountain valleys meet. The result is the magnificent cosmic web we explored earlier. Seen from far enough away, the observable universe resembles a continent sculpted by invisible geography. Its brightest cities of stars stand upon mountains no eye will ever directly witness. There is another quiet lesson hidden within these landscapes. Mountains on Earth do not remain forever. Wind slowly erodes them. Rain reshapes their slopes. Ice carves deep valleys. Yet, compared with human lifetimes, they seem almost eternal. Dark matter halos possess a similar patience. They evolve, they merge, they grow larger, but they do so over billions of years. A galaxy may complete dozens of revolutions before its invisible foundation changes appreciably. To the stars living within it, the mountain beneath them feels timeless. Perhaps that is why galaxies often appear so graceful. Their spiral arms turn slowly. Their stars orbit in remarkable harmony. The unseen landscape provides quiet stability. Without those hidden foundations, galaxies might never have survived long enough for planets and eventually life to appear. There is something profoundly beautiful about this idea. We often believe the most important things must also be the most visible. Nature gently suggests otherwise. The roots of a great tree remain buried. The foundation of a cathedral lies beneath its walls. The human heart beats unseen inside the body. And beneath every magnificent galaxy rests an invisible mountain, patiently holding everything together. Perhaps beauty has always depended upon hidden strength. The stars receive our admiration. The galaxies fill our telescopes. Yet beneath all their brilliance, silent mountains of gravity continue shaping the universe exactly as they have since its earliest days. And somewhere beyond the farthest galaxy visible tonight, another invisible summit quietly rises through the fabric of space, its slopes guiding billions of unseen stars, its valleys gathering tomorrow's galaxies, standing patiently beneath the cosmos. Like mountains no sunrise will ever reveal. 6. The worlds waiting beyond every map. Far beyond the familiar galaxies may drift lonely worlds whose night skies have been almost completely empty for billions of years. Imagine opening an old map of the world. At its edges, the coastlines suddenly end. Beyond them, the parchment simply reads, "Here be unknown seas." For centuries, people believed those blank spaces marked the limits of the known world, not because nothing existed beyond them, but because no one had yet traveled far enough to find out. In many ways, our understanding of the universe still resembles those ancient maps. We have charted billions of galaxies. We have followed rivers of invisible hydrogen stretching across the cosmic web. We have climbed hidden mountains of dark matter and wandered through enormous empty voids. Yet beyond every map we have carefully drawn, the universe continues, quietly, patiently, almost certainly holding places we have never imagined. Among those possibilities is one of the most haunting ideas in modern astronomy. There may be lonely worlds drifting so far from every familiar galaxy that their skies have remained almost completely empty for billions of years, not because stars no longer exist, but because home itself has disappeared behind an endless ocean of darkness. Tonight, we'll imagine these forgotten worlds. We'll explore how planets might survive journeys between galaxies, why some stars are destined to wander forever, and what the night sky might look like from a place where the universe itself seems to have vanished. When we think of planets, we naturally picture them as loyal companions. Earth belongs to the sun. The planets of our solar system travel together through the Milky Way. Every night, familiar stars surround us. It feels comforting, permanent, almost inevitable. But the universe rarely promises permanence. Galaxies are not quiet museums where stars remain forever in assigned places. They are dynamic systems constantly changing over billions of years. Stars pass close to one another. Massive black holes influence stellar orbits. Galaxies collide. Clusters merge. Gravity continually rearranges the architecture of the cosmos. Occasionally, those encounters become so dramatic that an entire star is thrown away. Astronomers call these hypervelocity stars. Some race through space at more than 1,000 kilometers every second. That is fast enough to escape the gravitational pull of the Milky Way entirely. Most are believed to receive this extraordinary speed after close encounters with the supermassive black hole at the center of our galaxy. Others may be launched during collisions between galaxies or through complex gravitational interactions involving multiple stars. Whatever the cause, the result is astonishing. A star leaves home forever. Imagine tossing a single glowing ember from a campfire. The fire continues burning behind it, but the ember flies alone into the darkness. Some hypervelocity stars may spend billions of years crossing the enormous distances between galaxies. If one of those stars happened to possess planets, those worlds would accompany it. Entire solar systems could quietly leave their galaxies behind, not by choice, not by catastrophe, simply because gravity whispered, "Go." At first, the departing planets would still enjoy familiar skies. Their home galaxy would remain visible behind them, growing gradually smaller as the centuries passed. Millions of years later, it might resemble an unusually bright spiral hanging in the distance. Hundreds of millions of years later, even that magnificent sight would shrink into little more than a fuzzy patch of light. Eventually, home would become almost impossible to distinguish from the countless distant galaxies scattered across the universe. The familiar constellations would disappear forever. Every night would reveal a different sky, one shaped not by nearby stars, but by unimaginable isolation. What would it feel like to stand on such a world? If intelligent life evolved there, its earliest astronomers might never suspect they lived outside a galaxy. Their own sun would dominate the sky. Perhaps a few nearby companion stars, if any remained gravitationally bound, would still shine. Beyond them, darkness. Only the faint glow of incredibly distant galaxies scattered across an almost perfectly black sky. Without the bright band of the Milky Way stretching overhead, they might conclude that the universe contained only a few lonely islands of light. Their entire picture of cosmology would begin from solitude. Perspective changes everything. Even more extraordinary are the mysterious rogue planets. Unlike Earth, these worlds orbit no star at all. Some formed inside planetary systems before being thrown into interstellar space by gravitational encounters. Others may have collapsed directly from small gas clouds, never truly belonging to any star. Astronomers estimate that our galaxy alone may contain billions of these wandering planets, cold, dark, invisible. They drift silently through the Milky Way, like forgotten ships crossing an endless ocean. Now imagine a rogue planet that somehow escapes not only its parent star, but eventually its entire galaxy. Such a world would become one of the loneliest places imaginable. No sunrise, no sunset, no neighboring stars decorating the sky. Only distant galaxies glowing faintly beyond unimaginable darkness. Could life survive there? At first, the answer seems obvious. Without sunlight, surely every ocean would freeze solid, every atmosphere would collapse, every possibility for biology would disappear. Yet nature has surprised us before. Here on Earth, entire ecosystems thrive around deep-sea hydrothermal vents without relying on sunlight. The heat comes from Earth's interior. Chemical reactions provide energy. Some scientists have suggested that sufficiently large rogue planets, insulated by thick atmospheres or heated internally through radioactive decay, might maintain liquid oceans beneath frozen surfaces for billions of years. Life, if it emerged before the planet became a wanderer, or somehow afterward, might continue quietly beneath layers of ice. Never seeing a sunrise, never knowing what stars truly look like. Imagine an intelligent civilization evolving beneath such an ocean. Their myths would contain no constellations, no dawn, no sunset. The concept of a galaxy might sound like pure fantasy. Only after developing advanced instruments capable of detecting faint distant light would they slowly realize that beyond the ice, beyond the darkness, beyond their lonely planet, an unimaginably vast universe had always existed. Sometimes the greatest discoveries begin with realizing how incomplete our maps truly are. The future of the cosmos may create even more worlds like these. As the universe continues expanding, galaxies not bound together by gravity drift farther apart. Trillions of years from now, many galaxies will have disappeared beyond one another's observable horizons. Civilizations living in that distant future may never witness the magnificent cosmic web we see today. To them, their local galaxy might appear to be the entire universe. Everything beyond will have faded from view. In a strange way, the cosmos itself is slowly creating more isolated worlds. The map grows smaller, even while the universe grows larger. There is something deeply poetic about these imagined places. Human beings have always been explorers. Every generation has believed it reached the edge of the known world. Then someone sailed farther, climbed higher, looked deeper. The blank spaces slowly disappeared. Astronomy continues that ancient tradition. Every powerful telescope extends the map a little farther. Every new discovery reminds us that the unknown is usually much larger than the familiar. Perhaps the greatest frontier has never been the places we already know. Perhaps it has always been the quiet worlds waiting beyond every map. Worlds where the night sky tells an entirely different story. Worlds whose lonely stars have crossed unimaginable distances. Worlds where home became only a fading memory carried by light that will never return. And somewhere tonight, far beyond the crowded neighborhoods of the cosmic web, a solitary star continues its endless journey between galaxies, its silent planets faithfully following behind, their skies growing darker with every passing million years, drifting patiently toward horizons no map has ever reached, waiting beneath an almost empty universe for someone someday to imagine that they might be there. 7. The first footprints of gravity. Before the first sunrise in the universe, gravity had already begun leaving invisible footprints that every future galaxy would eventually follow. Imagine waking before dawn after a fresh snowfall. The world is perfectly silent. No birds are singing. No sunlight has touched the hills. Everything seems untouched. Then, just ahead of you, you notice a trail of footprints crossing the snow. Someone had already been there, long before the morning began, long before anyone else arrived. Those footprints quietly tell the story of everything that followed. The universe has footprints like these, not pressed into snow, not carved into stone, but left in the invisible fabric of space itself, long before the first star ignited, before the first galaxy spun gracefully through the darkness, before the universe experienced its very first sunrise. Gravity had already begun walking across the newborn cosmos, patiently, silently, leaving pathways that future galaxies would spend billions of years following. Tonight, we'll travel back farther than ever before, to an era when there were no stars to illuminate the darkness, no planets, no constellations, only the faintest whispers of gravity quietly sketching the blueprint of everything that would one day exist. Because sometimes, the most important journeys begin long before anyone notices the first step. If we could somehow travel backward through time, leaving today's universe behind, the familiar night sky would gradually disappear. The Milky Way would unravel. Its spiral arms would fade. Young stars would vanish first. Then older generations would disappear as well. Galaxies themselves would become smaller, simpler, less organized, continue traveling farther back, and eventually, every galaxy would dissolve into enormous clouds of gas. Go back even farther, and even those clouds disappear. For a brief moment after the Big Bang, the universe contained no stars at all, no planets, no galaxies, nothing resembling the beautiful cosmos we know today. Instead, space was filled with an incredibly hot mixture of light and tiny particles. It was bright beyond imagination, yet strangely, there was nothing that could truly be called a sunrise. Sunrises belonged to stars. Stars had not yet been born. This early universe looked almost astonishingly smooth. Matter spread in nearly every direction with remarkable uniformity. If you could somehow observe it from above, it might resemble a calm ocean stretching endlessly beneath a cloudy sky. At first glance, it seems impossible that such a smooth beginning could ever produce galaxies, planets, mountains, oceans, or life. Where could complexity possibly come from? The answer lies in imperfections so tiny that they almost escaped existence altogether. The young universe was not perfectly smooth. Some places contained just a little more matter than average. Others contained just a little less. The differences were extraordinarily small. Imagine an ocean whose waves differ in height by less than the thickness of a human hair. To us, the surface would appear perfectly flat. Yet gravity noticed every tiny ripple. Unlike light, gravity never becomes impatient. It does not require dramatic differences. Even the slightest imbalance is enough. One extra grain of sand, one additional drop of rain. Given enough time, everything changes. Those tiny regions containing slightly more matter possessed slightly stronger gravity. That stronger gravity attracted just a little more material. As more matter gathered, gravity became stronger still. The process repeated again and again, almost unbelievably slowly. No explosions, no sudden miracles, only quiet accumulation, like snowflakes settling upon a distant mountain one by one. Perhaps this is the universe's greatest lesson in patience. Nothing spectacular happened overnight. Gravity simply refused to stop. Modern observations allow us to glimpse these ancient footprints directly. The oldest light in the universe, the cosmic microwave background, still surrounds us today. It began its journey about 380,000 years after the Big Bang, when the universe cooled enough for light to travel freely through space. To human eyes, it appears invisible, yet sensitive instruments reveal something extraordinary. Tiny variations in temperature spread across the sky. Some regions are ever so slightly warmer, others slightly cooler. These delicate patterns represent the earliest visible fingerprints of the universe's structure. They are, in many ways, gravity's first footprints, frozen forever in ancient light. When astronomers study those subtle patterns, they are not merely looking at old radiation. They are reading the opening page of cosmic history. Every bright cluster of galaxies, every graceful spiral, every lonely dwarf galaxy, every immense filament stretching across the cosmic web, can trace its ancestry back to one of those almost invisible ripples. It is rather like examining the rings inside an ancient tree. Each ring tells the story of earlier seasons. Likewise, every galaxy quietly remembers the tiny fluctuation from which it eventually grew. But gravity did not work alone. Dark matter, the invisible substance we've encountered throughout our journey, played an equally important role. Unlike ordinary matter, dark matter did not interact with light. It remained free to gather into clumps while the young universe was still glowing intensely. Long before ordinary hydrogen could fully collapse into stars, dark matter had already begun constructing enormous gravitational foundations. Imagine builders arriving at an empty field long before sunrise. While the surrounding town still sleeps, they quietly lay roads, dig foundations, mark future streets. By the time daylight arrives, the invisible framework for an entire city already exists. The first galaxies inherited exactly that kind of hidden preparation. Ordinary matter simply followed pathways gravity had already outlined. Hydrogen drifted into invisible valleys. Clouds became denser. Temperatures slowly increased. Hundreds of millions of years later, the first stars finally ignited. To anyone watching only from that moment onward, it might seem as though the stars had suddenly appeared. But the real work had begun long before. The sunrise was merely the visible ending of a story gravity had quietly started ages earlier. Perhaps that is why astronomers often describe the universe as growing rather than being assembled. Growth happens from within. A seed contains invisible instructions long before it becomes a towering oak. The first green leaves seem miraculous, yet every branch was quietly prepared inside the seed itself. The cosmos followed the same gentle rhythm. The galaxies were never dropped randomly into space. They grew naturally from ancient patterns, almost as old as time itself. As billions of years passed, gravity's original footprints became increasingly pronounced. Small clouds merged into larger ones. Tiny galaxies joined together. Clusters formed. Filaments stretched across unimaginable distances. Eventually, the magnificent cosmic web emerged, a vast network connecting nearly every galaxy in the observable universe. Looking at that immense structure today is rather like flying above an ancient landscape where countless generations have followed the same footpaths. The trails become roads, roads become highways. Highways connect entire civilizations, yet every great journey began with a single quiet footprint. There is something profoundly comforting about this slow unfolding. Human beings often expect important changes to happen suddenly. The universe rarely agrees. Its greatest masterpieces emerge through astonishing patience. One gentle pull, one tiny imbalance, 1 billion years after another. Even today, gravity continues following those same ancient footprints. Galaxies still merge. Clusters continue growing. Fresh stars are born inside quiet clouds of hydrogen. Nothing about gravity has changed since the beginning. The same invisible force that guided the first atoms together now keeps Earth circling the sun. It shapes the tides. It holds galaxies together. It gently anchors your feet to the ground beneath you. One law, one patient story. Written across nearly 14 billion years, perhaps that is the most beautiful realization of all. The universe did not become magnificent because something extraordinary happened only once. It became magnificent because something ordinary never stopped happening. Gravity simply kept walking, quietly, faithfully, leaving one invisible footprint after another across the newborn cosmos. And somewhere beyond the reach of every telescope, those first footsteps are still echoing, hidden beneath every galaxy, every star, every planet, quietly reminding us that the universe's greatest journey began long before its first sunrise ever painted the darkness with light. If you're enjoying these relaxing stories from across the cosmos, subscribing helps us continue exploring one peaceful mystery at a time. 8. The quiet winds between the stars. Space may seem perfectly still, yet enormous invisible winds have been flowing between galaxies since the universe was young. Imagine standing in the middle of a peaceful meadow. The trees are perfectly still. The grass barely moves. The air feels completely calm. It seems as though nothing is happening. Then you notice a single feather drifting slowly across the field. Moments later, a few leaves begin to slide quietly along the ground. Only then do you realize a gentle wind has been blowing all along. It was simply too soft to notice. The universe is filled with winds like these, not made of air, not carrying the scent of rain or the warmth of summer, but enormous invisible streams of gas, charged particles, and ancient atoms that have been flowing silently between galaxies for billions of years. No human ear could ever hear them. No flag could flutter beneath their breath. Yet, these quiet cosmic winds have helped shape galaxies, feed newborn stars, and recycle the very atoms that would one day become planets. and perhaps even us. Tonight, we'll drift with these invisible currents. We'll discover why space is far less motionless than it appears, how entire galaxies breathe without lungs, and why the calmest places in the universe may actually be filled with slow-moving rivers of endless wind. When people first imagine outer space, they often picture perfect stillness. Astronauts float silently. Stars appear frozen against the black sky. Nothing seems to move except planets following predictable orbits. Compared to Earth's constantly changing weather, the universe feels almost lifeless. But appearances can be wonderfully deceptive. Space is never truly still. Even the emptiest regions contain wandering atoms. Clouds of hydrogen drift through the darkness. Charged particles race away from exploding stars. Entire galaxies move through thin oceans of nearly invisible gas. Everything flows, just far more slowly than human eyes are accustomed to seeing. Perhaps the easiest place to begin is surprisingly close to home. Our own sun constantly releases a stream of charged particles known as the solar wind. Every second, millions of tons of material escape from the sun's outer atmosphere. These particles race outward at hundreds of kilometers per second. They sweep across the solar system, brushing against every planet they encounter. Earth survives this constant breeze because of its magnetic field. Invisible magnetic lines gently guide most of the solar wind around our planet, like water flowing around a smooth stone in a river. Occasionally, however, some particles slip through near the poles. When they collide with atoms high in our atmosphere, the sky blossoms into shimmering curtains of green and red light. The auroras are, in many ways, visible fingerprints left behind by an invisible wind. Yet the solar wind is only a tiny whisper compared to the much larger currents moving through galaxies themselves. Every galaxy is alive with motion. Massive young stars shine so intensely that their radiation pushes surrounding gas outward. When those stars eventually explode as supernovae, they launch enormous shockwaves across interstellar space. Thousands, sometimes millions, of stars working together create something extraordinary. They generate galactic winds. These immense outflows carry gas, dust, and newly forged elements far beyond the visible edges of galaxies. Imagine standing near a great forest in autumn. A gentle breeze lifts thousands of leaves into the sky. Some fall nearby, others travel astonishing distances before settling back to the ground. Galactic winds perform a remarkably similar task, except instead of leaves, they carry carbon, oxygen, silicon, iron, the very ingredients future stars and planets require. Without these quiet winds, many galaxies would slowly trap all their heavy elements within themselves. Future generations of stars would inherit far fewer building blocks. The universe would become far less creative. Instead, nature prefers sharing. One generation of stars quietly prepares material for the next. The winds become messengers, carrying ancient atoms across unimaginable distances. Some of these outflows are so powerful that they escape their galaxies entirely. They drift into the vast intergalactic medium, the enormous reservoir of gas stretching between galaxies. There, the material joins the invisible rivers we explored during our previous journey. Fresh hydrogen slowly flows inward. Enriched gas sometimes flows outward. Together, they create a magnificent cosmic circulation. Galaxies are not isolated islands. They breathe, very slowly, very quietly. They inhale ancient hydrogen from intergalactic space. They exhale heavier elements forged inside generations of stars. No lungs, no heartbeat. Yet the rhythm continues across billions of years. Modern astronomers sometimes describe this process as the galactic baryon cycle. It is one of the great recycling systems of the cosmos. The carbon inside your body, the oxygen filling your lungs, the calcium within your bones. Each atom may have traveled through several stars, been carried by galactic winds, drifted through interstellar clouds, before eventually becoming part of Earth. In a profound sense, every breath we take contains memories of ancient cosmic weather. Some of the most dramatic winds in the universe come from the centers of galaxies. There, enormous, supermassive black holes quietly wait. When gas falls toward these giants, not all of it disappears beyond the event horizon. Some become so intensely heated that powerful jets and outflows blast material back into surrounding space. These winds can travel thousands of kilometers every second. Over millions of years, they influence entire galaxies. Sometimes they compress distant clouds, encouraging new stars to form. Other times they sweep gas away, slowing star formation for hundreds of millions of years. Even black holes, often imagined as cosmic destroyers, participate in the universe's gentle circulation. The winds they create do not merely erase, they reshape. There is another kind of motion occurring between galaxies that is almost impossible to imagine. Entire galaxy clusters drift through extremely thin, incredibly hot gas, filling the spaces between them. As galaxies move through this medium, they experience something rather like a breeze. Astronomers call one fascinating consequence ram pressure stripping. Gas inside smaller galaxies is gradually swept away as they plunge through the hot intercluster environment. Long tails of hydrogen stretch behind them, sometimes reaching hundreds of thousands of light years into space. Seen from afar, these galaxies resemble glowing jellyfish drifting through a cosmic ocean. The universe has weather on every scale. What appears motionless from a distance often reveals astonishing movement upon closer inspection. Even the great cosmic web itself is never entirely still. Hydrogen continues flowing along invisible filaments. Galaxies slowly drift toward dense clusters. Dark matter quietly guides enormous currents across hundreds of millions of light years. Nothing stands frozen. Everything participates in the same patient circulation. The pace is simply so gentle that the universe appears peaceful. Perhaps that is why astronomy often teaches us to think differently about time. On Earth, winds change within hours. Storms arrive overnight. Seasons transform entire landscapes within months. Cosmic weather unfolds across millions, or even billions, of years. If human history were compressed into a single heartbeat, these invisible winds would still seem almost motionless. Yet, given enough time, they reshape galaxies, build future solar systems, scatter the ingredients of life across the cosmos. There is something deeply comforting about that idea. Nature rarely wastes anything. Stars live. They shine. They release their atoms. The winds carry those atoms onward. New stars form. New planets appear. The journey begins again. Nothing is truly lost. Everything becomes part of another story. Perhaps the universe has always preferred gentle movement over sudden endings. The strongest forces are not always the loudest. The greatest changes are not always the fastest. Sometimes, a quiet wind blowing patiently through darkness for billions of years can accomplish more than the brightest explosion ever could. And somewhere tonight, beyond the glowing spiral arms of the Milky Way, ancient winds continue drifting silently between the stars, carrying forgotten atoms from long-dead suns, preparing clouds that have not yet become new stars, crossing the endless darkness so gently that the universe itself almost seems to be breathing in its sleep. 9. The light that outlived its own galaxy. Some ancient light may still be traveling across space, even though the galaxies that first released it have long since disappeared. Imagine receiving a handwritten letter. The paper has yellowed with age. The ink has begun to fade. You unfold it carefully and discover that it was written hundreds of years ago. The person who penned those words is long gone. Their home no longer stands. Their town may have changed beyond recognition. Everything that surrounded them has disappeared, yet somehow, their message has survived. It continued traveling through time long after its creator was gone. Light can do something remarkably similar. Every beam of starlight is a message. It carries the story of where it began, the temperature of the star that produced it, the elements it passed through, the direction from which it came. And because light moves at a finite speed, every message arrives late. Sometimes a few minutes late, as sunlight does on Earth. Sometimes millions, or even billions, of years after it first began its journey. That means some of the oldest light reaching us tonight may have started traveling from galaxies that no longer exist in the form that created it. The stars have changed. The galaxies have collided. Some have merged into entirely new systems. Others have been torn apart by gravity. Yet, their ancient light continues drifting across the universe, faithfully carrying memories of places that time itself has already erased. Tonight we'll follow those extraordinary messages. We'll discover how light becomes the universe's oldest historian, why the night sky is filled with ghosts that are not truly ghosts, and how every glance toward the distant cosmos becomes a journey into places that have already become history. Light never forgets where it came from. Once a photon begins its journey, it carries its story across unimaginable distances. Unlike people, light never grows tired. Unlike civilizations, it never ages in the way we understand. For the photon itself, according to the strange rules of relativity, the journey is timeless. Yet, from our perspective, that same voyage may last billions of years. Imagine shining a flashlight across a valley. The beam reaches the opposite hillside almost instantly. Now imagine increasing that valley until it stretches across 10 billion light years. The flashlight would still behave exactly the same way. Only the waiting becomes unimaginable. The universe is so vast that much of the light entering our telescopes tonight began traveling long before Earth resembled the world we know today. Some photons left their galaxies before the dinosaurs existed. Others departed before our solar system had fully formed. A few began their journey when the universe itself was still young. Those ancient travelers have crossed expanding space without stopping once, not pausing, not turning around, simply continuing, patiently, until they finally meet a telescope, or perhaps a human eye. When astronomers point powerful observatories toward distant galaxies, they are never seeing those galaxies as they exist today. They are seeing memories. A galaxy located 1 billion light years away appears exactly as it looked 1 billion years ago. A galaxy 10 billion light years away appears 10 billion years younger. The farther we look, the farther back in time we travel. This is one of the most extraordinary gifts nature offers. The universe preserves its own history simply because light requires time to cross space. Suppose we could somehow observe Earth from a civilization 66 million light years away. Tonight, they would not see modern cities. They would not see satellites circling the planet. They would not even know humanity existed. Their telescopes would reveal a world where dinosaurs still walked beneath ancient forests. Our present would remain hidden inside light that has not yet reached them. Across the cosmos, every observer lives inside a different chapter of the same story. Some are watching our distant past. Others would see a younger Milky Way. Still others observe galaxies that have already transformed beyond recognition. Time becomes woven into distance itself. Galaxies are never truly permanent. Over billions of years, gravity constantly reshapes them. Small galaxies merge into larger ones. Spiral galaxies collide, eventually becoming giant elliptical systems. New stars ignite. Old stars quietly fade. Entire populations of suns complete their lives. Consider our own future. Roughly 4 to 5 billion years from now, the Milky Way and Andromeda will begin an enormous gravitational dance. Their elegant spiral arms will stretch, twist, and slowly dissolve. After hundreds of millions of years, the two galaxies will merge into one much larger system. Astronomers sometimes call this future galaxy Milky. Now imagine a beam of light leaving the Milky Way tonight. It begins its journey while our galaxy still possesses graceful spiral arms. 10 billion years later, that photon finally arrives somewhere unimaginably distant. Whoever receives it will witness a galaxy that no longer exists. The spiral Milky Way will have vanished billions of years earlier. Yet its ancient appearance survives inside that single beam of light. The message outlives the place that created it. This happens throughout the universe every moment. Some distant galaxies we observe are already radically different today. Many have merged with neighbors. Some have consumed smaller companions. Others have exhausted much of the gas needed to create new stars. The beautiful youthful systems we admire through our telescopes are often photographs of cosmic childhood. The adults they became remain hidden because their newer light has not yet reached us. In this sense, astronomy is unlike any other science. A geologist studies rocks existing today. A biologist observes living organisms in the present. But astronomers routinely investigate objects that no longer exist in the forms they observe. Every observation becomes an act of historical archaeology. The universe keeps its archives written in light. Perhaps the greatest archive of all is the cosmic microwave background. This faint glow surrounding the entire sky began its journey nearly 13.8 billion years ago. It is not the light of stars. Those had not yet formed. Instead, it comes from the moment the young universe first became transparent, allowing photons to travel freely through space. Those photons have been wandering ever since. Long before the Milky Way existed, long before Earth formed, long before the first living cell appeared, they continued traveling. Tonight, tiny portions of that ancient light quietly pass through your room. Some enter radio telescopes high on remote mountaintops. Others continue onward into deeper space. Messages almost as old as time itself. There is another beautiful consequence of this endless journey. Light does not merely preserve images, it preserves chemistry. As photons pass through clouds of hydrogen, oxygen, carbon, and countless other elements, tiny portions of specific wavelengths disappear. Those missing colors become delicate fingerprints. By studying them, astronomers discover what ancient galaxies were made of, how quickly they formed stars, how fast they moved. Even though the galaxies themselves may have transformed completely, their ancient light still whispers their secrets. It is as though an old letter carried not only words, but also the scent of its writer's home. Sometimes we casually refer to distant galaxies as looking into the past. But perhaps an even gentler way to think about it is this: the universe never truly forgets. Every important moment sends light outward in every direction. That light continues carrying its memory for as long as space allows, even if every star eventually burns out, even if galaxies merge beyond recognition. Their oldest messages continue crossing the darkness. History itself keeps traveling. Perhaps there is something comforting in that thought. Human lives feel brief. Civilizations rise and fall. Mountains slowly erode. Even galaxies cannot escape change. Yet every sunrise leaves behind light that will continue traveling long after the sunrise itself has ended. Every star writes a message. Every galaxy signs its name. The universe quietly becomes a library whose books are written not with ink, but with photons. And somewhere tonight, far beyond the edge of every familiar constellation, a tiny particle of ancient light continues its endless voyage, still carrying the image of a beautiful spiral galaxy that disappeared billions of years ago. Faithfully preserving a moment the universe itself has already left behind, waiting patiently for someone, somewhere. to finally read its timeless message. 10. The invisible architects of every galaxy. Every spiral galaxy you admire tonight may have been shaped by builders that have never emitted a single ray of light. Imagine arriving in an ancient city just before dawn. Towering cathedrals rise into the morning sky. Stone bridges stretch gracefully across quiet rivers. Grand avenues connect bustling neighborhoods. Every building seems perfectly placed, as though the entire city had been carefully planned centuries before. Yet the architects themselves are nowhere to be found. No portraits remain. No names are carved into the walls. No records tell us who first imagined these magnificent streets. Only the city itself survives, its beauty quietly revealing the work of invisible hands. The universe may have been built in much the same way. Every graceful spiral galaxy, every enormous cluster of stars, every elegant river of glowing gas winding through the darkness. They all seem astonishingly well organized, almost designed. Yet the builders responsible for that structure have never been directly seen. They emit no light, cast no shadow, leave behind no visible monument. And still, their work surrounds us every time we look into the night sky. Tonight, we'll meet these invisible architects. We'll discover how unseen structures quietly designed the galaxies long before the first stars appeared. Why light alone tells only part of the universe's story, and how the greatest builders in existence may remain forever hidden behind their own creations. Human beings naturally notice the finished masterpiece. We admire the cathedral, the bridge, the sculpture standing proudly in the sunlight. Rarely do we think about the wooden scaffolding that once surrounded the building, the surveyors who measured the land, the foundations buried beneath the streets. Yet, without those hidden preparations, the visible beauty would never have existed. Astronomy has taught us a remarkably similar lesson. For thousands of years, people believed the stars themselves were the primary building blocks of the universe. Galaxies appeared to be magnificent collections of glowing suns. Everything important seemed visible. Then, during the 20th century, astronomers began discovering quiet mysteries. Stars near the edges of galaxies moved much faster than expected. Entire galaxy clusters remained gravitationally bound, despite containing far too little visible matter. Light from distant galaxies bent around invisible masses scattered throughout space. Again and again, the same conclusion emerged. Something unseen was quietly shaping everything. Today, we call that mysterious substance dark matter. Although no telescope has ever photographed it directly, its gravitational influence appears almost everywhere we look. In fact, scientists estimate that ordinary matter, the stars, planets, gas, dust, and even ourselves, accounts for only a small fraction of the universe's total matter. Most of the cosmic architecture appears to rest upon invisible foundations. Imagine visiting a vast forest in winter after a heavy snowfall. The snow covers every root beneath the ground. Looking across the landscape, you see only white fields interrupted by towering trees. The roots remain hidden, yet every tree stands exactly where those unseen roots allow it to grow. Dark matter behaves rather like those invisible roots. It spread through the young universe long before galaxies fully existed. While ordinary matter remained tightly coupled to intense radiation during the universe's earliest years, dark matter quietly gathered under its own gravity. Small clumps slowly became larger. Large clumps merged into enormous halos. These halos became the first construction sites of the cosmos. Only later did ordinary hydrogen begin falling into those invisible gravitational wells. As the gas accumulated, it cooled. Clouds formed. Gravity continued tightening its embrace. Eventually, the first stars ignited. From our perspective, it looks as though galaxies built themselves from glowing matter. But in reality, much of their invisible framework had already been completed. The architects finished the foundations, before anyone noticed the building rising above them. This process explains one of the most beautiful patterns in the observable universe. Galaxies rarely appear scattered randomly. Instead, they gather along enormous filaments, stretching across hundreds of millions of light years. Clusters form where several filaments intersect. Between them lie immense cosmic voids. This magnificent arrangement is known as the cosmic web. When astronomers simulate the growth of the universe using only ordinary matter, something feels incomplete. Galaxies struggle to form quickly enough. The large-scale structures never fully resemble what our telescopes actually observe. But once invisible dark matter is included, the simulations begin producing networks astonishingly similar to the real universe. It is rather like discovering an old architectural blueprint hidden beneath the floorboards of an ancient cathedral. Suddenly, every wall, every hallway, every window makes perfect sense. The visible building simply followed an invisible design. Perhaps the most remarkable part of this story is its patience. Dark matter never rushes. It does not shine dramatically like exploding stars. It does not announce its presence through brilliant colors or violent eruptions. Its influence unfolds almost entirely through gravity. Gentle, persistent, quiet. Over billions of years, that quiet persistence shapes galaxies larger than anything human imagination comfortably accepts. Nature often prefers whispers to fireworks. Even today, the invisible architects continue working. Our Milky Way is still slowly growing. Tiny dwarf galaxies orbit around it. Some will eventually merge into our galaxy, adding fresh stars and gas. The dark matter halo surrounding the Milky Way quietly guides those encounters. It determines many of the pathways future galaxies will follow. Construction has never truly stopped. The universe remains an active project. Only the pace is so slow that we rarely notice the changes. One fascinating consequence of these invisible foundations appears in the elegant spiral arms of galaxies. Although the exact formation of spiral patterns remains wonderfully complex, astronomers know they depend strongly upon the galaxy's overall gravitational environment. Stars move, gas clouds compress, new generations of suns ignite. The graceful spiral pattern emerges from countless individual motions, all taking place inside an invisible gravitational landscape. Every magnificent spiral you admire in telescope photographs owes part of its beauty to structures no eye can ever directly witness. It is rather like listening to an orchestra. The audience hears the music, but hidden beneath every melody lies an invisible mathematical structure. Rhythm, harmony, timing. Without them, the performance dissolves into noise. The architecture remains unseen. Its beauty becomes visible only through its effects. Dark matter composes the rhythm of galaxies. There is another gentle mystery that scientists continue exploring. What exactly is dark matter? Despite decades of research, no one yet knows for certain. It does not appear to be made of the familiar atoms composing stars and planets. It rarely interacts with ordinary matter except through gravity. Powerful detectors buried deep underground patiently wait for tiny signals. Particle accelerators search for clues. Space telescopes continue mapping its influence across the cosmos. So far, the architects remain anonymous. Perhaps that uncertainty makes the story even more beautiful. The universe still keeps some of its greatest secrets. Every answer humanity discovers opens another quiet door leading toward deeper questions. The night sky remains not only a collection of stars, but an invitation, an unfinished conversation. There is something deeply comforting about invisible architects. In our own lives, many of the most important things also remain unseen. Love cannot be photographed. Trust has no color. Memory leaves no shadow. Yet, these invisible realities quietly shape entire lives. The universe seems to follow a similar philosophy. Its brightest galaxies rest upon unseen foundations. Its grandest structures emerge from forces no eye can directly observe. Perhaps visibility has never been the true measure of importance. Sometimes, the strongest builders are the quietest ones. And somewhere beyond the reach of every familiar constellation, invisible architects continue their patient work, guiding rivers of hydrogen into newborn galaxies, preparing foundations for stars that have not yet begun to shine, building tomorrow's cosmos without ever asking to be seen, leaving behind only their magnificent creations, scattered like luminous cities across an endless sea of night. 11. The oldest neighborhoods in existence. While much of the universe has spent billions of years changing, a few ancient stellar neighborhoods have remained astonishingly peaceful since nearly the beginning of time. Imagine walking through an old village hidden deep within the mountains. The houses are weathered by centuries of rain. Ancient stone paths wind quietly between them. The trees have grown enormous. The river still follows the same gentle curve it did long before anyone alive today was born. Outside the valley, empires have risen and fallen. Cities have expanded. Roads have changed. Entire civilizations have disappeared. Yet somehow, this little village has remained almost untouched. Time seems to move differently there, not because the clocks tick more slowly, but because so little has disturbed its quiet rhythm. The universe has neighborhoods like these. While galaxies collide, stars explode, black holes consume wandering clouds of gas, and the cosmic web slowly reshapes itself over billions of years. Some ancient gatherings of stars have remained remarkably peaceful since almost the beginning of cosmic history. They are among the oldest surviving communities in existence, silent neighborhoods whose oldest residents were already shining when the Milky Way was still young, and whose quiet streets have witnessed nearly the entire history of the universe. Tonight, we'll wander through these extraordinary places. We'll discover how they survived while so much around them changed, why astronomers treasure them as living fossils, and how the oldest neighborhoods in the cosmos continue telling stories written almost at the dawn of time. If stars lived completely alone, their histories would be difficult to reconstruct. Each would travel its own path through the galaxy. Some would be born, others would quietly fade. Their stories would slowly scatter across billions of years. Fortunately, nature often prefers company. Many stars are born together. Inside enormous clouds of cold hydrogen, gravity gathers countless newborn suns almost simultaneously. These stellar siblings begin life as members of the same family. Most families eventually drift apart. Gravitational encounters slowly separate them. The galaxy gently pulls them in different directions. After hundreds of millions of years, many siblings no longer recognize one another. Yet, a few extraordinary families remain together, not for millions, but for billions of years. These remarkable communities are known as globular clusters. Imagine looking into the night sky and finding not a loose scattering of stars, but a perfectly rounded city containing hundreds of thousands of suns packed astonishingly close together. From a distance, globular clusters resemble glowing pearls suspended around the Milky Way. Soft, ancient, peaceful. Their beauty hides an even greater wonder. Many of them are almost unimaginably old. Some formed more than 12 billion years ago. That means these stellar neighborhoods appeared when the universe itself was only a small fraction of its current age, long before our sun existed, long before Earth formed, long before the familiar spiral arms of the Milky Way looked as they do today. These quiet clusters were already shining. One of the most famous examples is Messier 92, often called M92. It contains stars that formed when the universe was still in its cosmic youth. Another magnificent cluster, Messier 13, the Great Hercules Cluster, has quietly orbited the Milky Way for billions of years. Its countless stars have remained gravitationally bound through almost the entire history of our galaxy. Imagine living on a planet inside such a cluster. The night sky would be unlike anything we experience on Earth. Instead of a few thousand visible stars, hundreds of brilliant suns might illuminate the heavens. Some would appear almost as bright as our own moon. Constellations, as we know them, might never exist. The sky would seem permanently crowded, almost alive. Yet despite that extraordinary beauty, these neighborhoods are remarkably stable. Why? The answer lies in balance. Although the stars inside globular clusters orbit one another constantly, the entire system has settled into an elegant gravitational dance. Over billions of years, the fastest stars occasionally escape. Others slowly drift inward. The cluster gently rearranges itself, but it does so with incredible patience. Like an old town whose streets change little from one generation to the next. Everything moves, yet everything remains. Astronomers treasure globular clusters because they preserve some of the oldest surviving stars ever observed. Unlike younger stars, such as our Sun, these ancient residents contain very few heavy elements. Their chemical composition reveals the conditions of the early universe. When they formed, only a handful of generations of stars had lived and died before them. Elements like iron, carbon, and oxygen were still relatively rare. In a sense, these stars carry the fingerprints of cosmic childhood. By studying them, astronomers glimpse an era that no longer exists anywhere else. It is rather like discovering an ancient library whose books have remained untouched for thousands of years. The pages become windows into forgotten ages. There is another remarkable feature of these stellar neighborhoods. Most of them orbit far above and below the thin disk of the Milky Way. Rather than following the graceful spiral arms where young stars continue forming today, globular clusters travel through the galaxy's vast outer halo. This isolation has protected many of them from disruptive encounters. While the galactic disk remained busy creating new stars, merging with dwarf galaxies, and evolving continuously, these ancient clusters quietly completed orbit after orbit around the Milky Way. They became peaceful observers of history rather than active participants. Some have likely witnessed every major chapter of our galaxy's evolution. The birth of spiral arms, the arrival of neighboring dwarf galaxies, the slow growth of the central black hole, the formation of countless generations of stars, all while their own quiet communities remained largely intact. There is something wonderfully poetic about that. Human history often celebrates great change, empires expanding, technology advancing, cities transforming. Yet sometimes the greatest value belongs to places that simply endure, places that remember. Globular clusters are the universe's memory keepers. Each one quietly preserves a chapter almost as old as time itself. Modern telescopes continue uncovering their secrets. By measuring the motions of individual stars, astronomers can estimate the total mass of these clusters. By studying their colors, they determine stellar ages with remarkable precision. Some observations even suggest that tiny black holes may hide within certain clusters, while others reveal mysterious populations of exotic stars formed through close gravitational encounters. Even in the oldest neighborhoods, quiet surprises continue waiting. Time has not stopped there. It has simply become gentler. One day, trillions of years in the future, many familiar stars throughout the universe will have faded. Galaxies will change. Collisions will reshape enormous regions of space. Yet, some of these ancient clusters may still survive. Their longest-lived red dwarf stars will continue burning patiently. The quiet neighborhoods will remain, perhaps becoming among the final recognizable communities left in an aging universe. There is comfort in their persistence. We often imagine old things as fragile. Nature sometimes chooses the opposite. Some of the oldest structures become the strongest precisely because they have already survived so much. Every orbit strengthened their balance. Every billion years refined their harmony. The passage of time became not their enemy, but their greatest achievement. Perhaps that is why these ancient neighborhoods feel strangely familiar. Every community, whether among people or stars, is built upon relationships that quietly endure. The brightest moments may come and go. New generations arrive. Old ones slowly disappear. Yet the neighborhood itself continues carrying memories forward, one quiet story after another. And somewhere tonight, high above the glowing spiral arms of the Milky Way, an ancient cluster of hundreds of thousands of stars continues its silent orbit, its oldest residents shining almost exactly as they did 12 billion years ago. Watching galaxies evolve, watching civilizations someday rise beneath younger suns, more patiently preserving one of the oldest neighborhoods the universe has ever known. 12. The quiet pattern. Hidden across the universe. The galaxies above us may look scattered at random, but together they reveal one enormous pattern that has been growing for nearly 14 billion years. Imagine climbing a hill on a quiet evening. Below you lies a small town. From where you stand, the light seems scattered without order. One glows beside a river. Another shines from a lonely farmhouse. Dozens sparkle across distant hillsides. At first, they appear completely random, but then you climb a little higher. Suddenly, the scattered lights become streets. The streets become neighborhoods. The neighborhoods connect into an entire city. What once looked like chaos quietly reveals an elegant design that had been there all along. The universe invites us to make exactly the same journey. For thousands of years, people looked upward and saw only individual stars. Later, telescopes revealed galaxies. Then, larger telescopes uncovered clusters. Eventually, astronomers discovered immense rivers of galaxies stretching across hundreds of millions of light years. With every new step backward, a larger pattern slowly emerged. Today, we know that the galaxies above us are not scattered randomly across space. Instead, they form one of the greatest structures ever discovered, a quiet cosmic pattern that has been growing patiently since nearly the beginning of time. Tonight, we'll step back farther than ever before. We'll gather every mystery we've explored on this journey, the invisible rivers, the hidden mountains, the ancient winds, the oldest neighborhoods, the silent architects, and discover that they were never separate stories at all. They were always pieces of one magnificent design. Throughout our journey, we've wandered across many different corners of the cosmos. We visited galaxies that never stopped growing, lonely stars crossing the darkness between galaxies, invisible rivers carrying fresh hydrogen toward newborn suns, empty cosmic voids stretching across unimaginable distances, ancient globular clusters preserving some of the universe's oldest stars, invisible mountains of dark matter holding galaxies together. At first, each story seemed independent, like chapters taken from different books. But nature rarely works in isolation. Everything connects. Imagine standing close to a single tree. You notice its bark, its leaves, the gentle movement of its branches in the wind. Walk farther away, and suddenly you see the entire forest. Continue climbing into the sky, and the forest becomes part of a mountain range. Perspective changes understanding. The same is true of astronomy. When we focus on individual galaxies, we naturally admire their beauty. Graceful spiral arms, bright star-forming regions, ancient elliptical giants. But when we zoom outward far enough, those individual galaxies begin arranging themselves into something far larger. The cosmic web, enormous filaments of galaxies stretch like glowing threads across the observable universe. Where several filaments meet, immense galaxy clusters gather. Between them lie gigantic voids that contain remarkably few galaxies at all. It resembles a network, a web, perhaps even the delicate branching of neurons inside a human brain. or the roots of an ancient tree spreading beneath a forest floor. Nature seems surprisingly fond of repeating beautiful patterns across vastly different scales. The remarkable part is not merely that this structure exists, it is how it formed. Nearly 14 billion years ago, the universe began astonishingly smooth. Tiny fluctuations, almost unimaginably small, appeared within the young cosmos. Gravity quietly amplified those faint differences. Dark matter gathered. Hydrogen followed. The first stars ignited. Galaxies emerged. Clusters assembled. Filaments stretched farther. The cosmic web slowly unfolded. Nothing appeared instantly. Every chapter prepared the next. Just as a tiny seed eventually becomes a towering tree, today's universe grew from beginnings almost too subtle to imagine. That quiet growth still continues. Even now, galaxies drift along invisible filaments toward larger clusters. Small galaxies merge into larger ones. Fresh hydrogen flows inward. Ancient winds carry newly forged elements outward. The universe is not a finished sculpture standing motionless inside a museum. It is a living landscape, always becoming, never completely finished. One of the most beautiful discoveries of modern astronomy is that almost everything we can see depends upon things we cannot. Stars rely upon invisible clouds of hydrogen from which they formed. Galaxies rest inside dark matter halos. Galaxy clusters grow where hidden gravitational pathways intersect. Even the expansion of the universe itself appears influenced by mysterious dark energy. Visibility has never been the whole story. Again and again, nature quietly reminds us that foundations often remain unseen. Consider a magnificent cathedral. Visitors admire stained glass windows glowing in afternoon sunlight. Towering arches rise overhead. Beautiful carvings decorate every wall. Yet beneath all of that beauty lies an invisible foundation buried underground. Without it, none of the visible structure could survive. The universe follows remarkably similar principles. Its brightest galaxies rest upon hidden foundations laid billions of years ago. Perhaps that is why astronomy feels so humbling. Every answer reveals another invisible layer beneath it. Every discovery expands the mystery rather than ending it. We once believed stars were isolated lights. Then we discovered galaxies, then clusters, then superclusters, then the cosmic web. Each generation climbed another hill. Each discovered a larger city beyond the previous horizon. One cannot help wondering what future generations may eventually see. Perhaps there are patterns larger still, structures extending beyond today's observable universe. Connections we cannot yet imagine simply because our maps remain incomplete. History suggests that every cosmic map eventually grows. The blank spaces become smaller. The unknown retreats, only to reveal even greater mysteries waiting beyond. There is another quiet lesson hidden inside this enormous design. Although the universe spans nearly 14 billion years of history, it behaves with extraordinary patience. Gravity never hurries. Stars require millions of years to form. Galaxies need billions of years to mature. Clusters grow across unimaginable stretches of time. Nothing important seems rushed. Human lives unfold quickly. The universe prefers slower rhythms. Perhaps that is why looking into the night sky often feels strangely calming. Its greatest achievements remind us that remarkable things can emerge through quiet persistence. Not every masterpiece requires sudden change. Sometimes, gentle accumulation accomplishes far more. Throughout these peaceful journeys, we've followed forgotten photons older than civilizations, walked through neighborhoods older than our sun, listened to invisible winds, crossed rivers of hydrogen, climbed mountains made entirely of gravity. Each story seemed small when viewed alone. Together, they become something breathtaking, a universe that is neither chaotic nor perfectly ordered. Instead, it is beautifully connected. Every galaxy belongs to something larger. Every star inherits material from older generations. Every atom continues a journey begun long before Earth existed. Even we, sitting beneath tonight's sky, become tiny participants in that same cosmic pattern. The calcium inside your bones was forged inside ancient stars. The oxygen you breathe once drifted through invisible galactic winds. The iron flowing through your blood was created inside stellar explosions that occurred long before our solar system was born. In a very real sense, the pattern is not only above us, it is within us. Perhaps that is the quietest wonder of all. We spend our lives looking outward, searching for our place among the stars. The universe gently whispers that we have always belonged to it, from the first faint footprints of gravity to the invisible architects shaping galaxies, to the quiet neighborhoods where ancient stars still shine. Every chapter has been part of one continuous story, a story still unfolding tonight. And somewhere beyond the farthest galaxy, our telescopes can currently see. The cosmic pattern continues stretching into darkness, its invisible threads still weaving tomorrow's galaxies. Its quiet design still growing exactly as it has for nearly 14 billion years. Patiently, beautifully, waiting for curious minds to climb one more hill and discover that the universe has always been even more connected than we ever imagined. If these gentle explorations help you end your evening with a little more wonder, consider subscribing, and I'll be here for our next quiet journey through the universe.